Electrostatics, the branch of science that study about charges which are at rest, is electrostatics. When charges are at rest, there is a field from the charge. For example, from positively charged body, field lines is away from positively charged body. Whereas if the body is negatively charged, which is rest charge, here we are talking about rest charge, electrostatics. That means field lines is towards the negatively charged surface, towards the negatively charged surface. Generally, there is also force between 2-point charges. So, generally, the characteristics of charge, the force formed between point charge, rest charge, the field formed by charge which are at rest, charges which are at rest, generally studied under this lesson, electrostatics. Atoms consist of electrons, which is negatively charged, protons, which is positively charged, neutrons has no charge. The charged electrons and the protons are elementary particles because they carry a small amount of charges. The charge carried by electrons, one electron carries one electron, this is electron E, small e, negative raised to negative, which is equal to minus 1.6 times 10 to the power of minus 19 Coulomb. Coulomb is the SI unit of charge, whereas E raised to plus. This is proton, positive, E negative, electron, proton. 1.6 times 10 to the power of minus 19 Coulomb. The charge carried by proton is equal in magnitude within the charge carried by electrons. Electrons and the protons are elementary particles which carries a small, very small amount of charge carried by electrons and the protons. Generally speaking, atoms are neutral. Atoms are neutral. What does it mean neutral? For example, consider this is atom, an atom. This is the number of positive charge, proton, and the negative charge. If the number of positive charge is equal to the number of negative charge, this atom is said to be neutral. The net charge in neutral body is equal to 0. If so, that body is said to be neutral body. Here, under this, we are going to study about the process of converting neutral body into charged body. There are 3 ways of changing neutral body, just like this, into charged body. The first one is charging by rubbing. Charging by rubbing. This is the phenomenon of converting charged neutral body into charged body. When 2 neutral bodies are rubbed together, electrons may transfer from one body to another body. The body which gains electron is negatively charged, and the body which loses electron is positively charged. Negatively charged means if the number of negative charge is greater than the number of positive charge, that body is negatively charged. Whereas, if the number of positive charge is greater than the number of negative charge, that body is positively charged. But if number of electron, number of negative charge is equal to number of positive charge, that body is neutral. Under this, changing the neutral body into charged body is the process of converting neutral body into charged body. There are 3 ways. The first one is charging by rubbing. When 2 bodies are rubbed together, for example, this is a neutral sphere. A neutral sphere, if it is rubbed with rod, rod, this is also neutral. Let's say this is charged rod. Charged rod is wrapped within this sphere, neutral sphere. Electrons may transfer from the rod to the sphere. The sphere gained electrons and the rod lost electrons. So the rod is maybe positively charged, whereas since the sphere gains electrons, it is negatively charged. So this process of converting the neutral body into charged body is a wrapping process. The second one is charging by conduction. Charging by conduction. This is charging by touching or conduction. For example, this is a neutral sphere. If this neutral sphere is tied with negatively charged sphere, when they touch together, electrons may transfer from the rod to the sphere. The rod may gain some amount of electrons. Here, the sphere gains some amount of electrons. The number of negatively charged particles is greater than the number of positively charged particles. Because of this, the sphere can be negatively charged, whereas the rod is positively charged, when the rod and the sphere are in contact. This process of charging is charging by conduction. The third point is charging by induction. This is approaching without touching, charging by induction. The two bodies never in contact. For example, if this is a sphere, literal sphere, and this is a rod, let's say here, negative, this is positive. The rod is approach to negatively charged rod, approach to the sphere. At this time, since the rod is negatively charged, the protons, the positively charged particle is attracted by the rod. Because of this, the positive particles are collected to the left. They are attracted by the rod. Now, the negatively charged particles, electrons, are found at the left side of the sphere because they are repelled by the rod. At this time, we connect a wire within the sphere. This is said to be grounding, connecting the wire to the sphere. At this time, electrons flow through the wire towards the ground. This process is grounding. Now, some amount of electrons are lost from the sphere and we disconnect after the electrons are escaped from the sphere. Now, the sphere becomes positively charged. This process is said to be approaching without touching. It is also said to be charging by induction. Charging by induction. The next point is Coulomb's law. Coulomb's law. Coulomb is the name of the physicist that study about the charge, the force formed between 2-point charges. If charge Q, Q1 and Q2 let's say this is sphere 1 and another sphere 2 are found at certain distance r from each other. This is sphere 1 charge which carries a magnitude of charge q1 and sphere 2 carries a magnitude of charge q2. They are found at certain distance r from each other. According to this law, the force formed between these 2-point charge may be attractive force or it may be repulsive force. It depends on the sign of the charge carried by the two spheres. If the charge carried by each sphere is the same, it may be positive or it may be negative. If they carry the same sign of charge, repulsive force is formed between the two spheres. Whereas if they carry opposite sign of charge, positive or negative positive, the attraction force is formed between the two spheres. Anyways, there is a force between the two bodies. This force is directly proportional to the product of the charges and inversely proportional to the square of the distance between the two charges. This means mathematically force formed between the two charges is directly proportional to charge 1 times charge 2, the product of the charge. Charge 1 times charge 2, the product of the charge. Directly proportional. Directly proportional means if the magnitude of the charge is increased, the magnitude of force is also increased. But if the magnitude of the charge decreased, the magnitude of force is also decreased. And force is inversely proportional to the square of the distance between the two charges. If the separation between the charge increased, force becomes decreased. Force is inversely proportional to the separation or distance between the two charges. From this relation, Coulomb give an expression for the force formed between the two charges, which is given as force is equal to K times Q1 times Q2 over R square. This is said to be Coulomb's force. Coulomb's force. The force formed between the two charges is directly proportional to the product of the charge and inversely proportional to the square of the distance between them. K is affected by the medium in which the charges are placed. The value of K is equal to 9 times 10 to the power of 9 Newton meter square per Coulomb square. This is the value of K, which is the force constant. So this mathematical expression is Coulomb's force. Next point is the comparing gravitational force and electrostatic force. Newton's gravitational force, which is mathematically expressed as it is expressed by Newton, is equal to G times universal gravitational constant times mass 1 times mass 2 over R squared. This is Newton's gravitational force. This is Coulomb electrostatic force. Now, if we have electrons and protons and they are found at certain distance r from each other, in between these two particles, since they carry a charge, there is a force, electrostatic force. The charge carried by one electron is minus 1.6 times 10 to the power of minus 90 Coulomb. The charge carried by one proton is 1.6 times 10 to the power of minus 90 Coulomb. Since they carry a charge, there is a force, electrostatic force, Coulomb's force. So, electrostatic force is equal to K times E charge carried by electrons times E plus charge carried by proton over R squared. In similar way, electrons has its own mass. The mass of electron is around 9 times 10 to the power of minus 31 kilogram, and the mass of one proton is equal to 1.62 times 10 to the power of minus 27 kilogram. This is the mass of proton, and this is the mass of electron. Gravitational force. Newton's gravitational force is the force formed between 2 point masses. It does not depend on charge. It depends on mass. Whereas electrostatic force depends on charge. If there is no charge, there is no electrostatic force. If there is no mass, there is no gravitational force. So, since the two charges has mass, there is also gravitational force, which is equal to universal gravitational constant G times mass of electron times mass of proton over R squared. Now, the difference between the two forces, Newton's gravitational force, and Coulomb's force, electrostatic force, is the first one, the difference between them. The first one, the magnitude of electrostatic force is always greater than the magnitude of gravitational force. If you calculate the electrostatic force by using this value of charge and this value of charge, and the distance, let's say the distance between them is 1 meter. If you calculate electrostatic force by using these values and by using this expression, you have got certain value. And if you calculate the mass of electron and the mass of proton, as well as G has constant value and the distance between them is here calculated, the value you get here, electrostatic force, is much greater than gravitational force. This is the first one. The second one, electrostatic force is either attractive force or repulsive force. It depends on the sign of the charge. Whereas gravitational force is always attractive force. Gravitational force is always attractive force. Electrostatic force is either attractive force or repulsive force. The third one, gravitational force is formed between 2 point masses. Electrostatic force is always formed between point charges. If there is no charge, there is no electrostatic force. If there is no mass, there is no gravitational force. This depends on mass, this depends on charge. This is the difference between Newton's gravitational force and Coulomb's electrostatic force.